Can you even imagine a building so huge it can fit rockets taller than a skyscraper inside? It sounds like science fiction, but it's real. Today, we're taking a look inside a true icon of engineering, the gateway for humanity's biggest adventures, NASA's Vehicle Assembly Building, or the VAB.
And here it is, the absolutely massive interior of the VAB at Kennedy Space Center. It was finished way back in 1966 for one single monumental purpose: to build the mighty Saturn V rocket, the machine that was going to carry us to the moon.
Now, when you build something on this scale, you run into some pretty unique problems. This building is so enormous, it can literally create its own weather inside. They had to install a ridiculously powerful air conditioning system just to stop rain clouds from forming near the ceiling. It was basically a precision factory built on the scale of the pyramids.
So the VAB was the answer to a brand new, kind of crazy question. How on earth do you build a 363-foot-tall rocket, make sure it stays perfectly straight, and get it ready for a trip to another world? Turns out the only way to do it was to build it straight up, piece by piece. And just think about how complex that is for a second. We're not talking about stacking Legos here. Each stage weighed hundreds of tons, and it had to be lifted and connected with unbelievable care. The success of the entire Apollo program really came down to the flawless, careful work done right inside this one building. And you know what's really wild? Just how long it all took. This timeline for Apollo 11 shows you it was anything but a rush job. It was more like a slow, careful dance of heavy machinery that started almost 5 months before launch. And the grand finale? Placing the actual spacecraft on the very top. And this is why all that slow, painstaking work was so worth it. A whole fleet of Saturn V rockets, each one a masterpiece of engineering. Every single astronaut who walked on the moon started their journey right here. The VAB was quite literally the starting line for making history.
Okay, so how do you actually lift pieces of a moon rocket? You can't just call a standard crane company. You need some seriously specialized tools. Let's look at the absolute beasts of machinery that make this giant lift possible.
Just try to wrap your head around this number, 325 tons. That's how much the main overhead crane in the VAB's high bay can lift. It's one of the most powerful in the world, and it was custom built by a company called PAR Systems specifically for this job, handling priceless space hardware. But it's not just about raw power, right? It's about reach. The crane can lift things 462 feet up in the air. That's as tall as a 45-story building. It has to be able to get all the way to the very top of that fully stacked rocket. But here's where the real magic happens. It's not just some giant clumsy hook. These systems are incredibly precise. You're trying to position a rocket stage that weighs tons, and it has to line up perfectly. The margin for error? Pretty much zero. It's the ultimate blend of sheer power and surgical precision. And look, when you're listing a one-of-a-kind moon rocket, you absolutely cannot afford for anything to go wrong. That's why these cranes have what's called the X-SAM safety system. It's designed to be single-point failure-proof. Basically, if any one part of the lift system breaks, emergency brakes slam on instantly. Dropping a rocket is just not an option. And at the end of the day, it's not really about the machines, is it? It's about the people who operate them with such incredible skill. Folks like Tim Flacco, a technician who just perfectly captures that sense of pride. For the people who work inside the VAB, it's not just a job. It's their chance to be a part of history. You know, after the Apollo program ended, the VAB could have just become a museum, a cool relic of a bygone era. But it didn't. Instead, it adapted, it evolved, and it's just as vital today as it was back in the 60s. This comparison really tells the whole story. Back then, it was all about the Saturn V. Today, in those exact same assembly bays, teams are putting together the Space Launch System, or SLS, the rocket for the Artemis program that's going to take us back to the moon. The rocket is new, but the VAB's mission, it's exactly the same. The Saturn V was the OG, the very first tenet of the VAB. It's the whole reason this massive building even exists. Every single part you see here was carefully stacked inside those walls to create a true icon of power that defined a generation. And now, the VAB has a powerful new tenet. The SLS rocket, the heart of the Artemis missions, is the most powerful rocket ever built. It generates a mind-boggling 8.8 million pounds of thrust at liftoff.
The ambition just keeps getting bigger, and the VAB has grown right along with it.
So what's the big takeaway here? It's the VAB's incredible enduring legacy. It was the heart and soul of Apollo, it was the factory for the entire space shuttle fleet, and now it's absolutely essential for the Artemis missions. For more than half a century, anytime America has aimed for the stars, the journey started right here. I mean, come on, is there a more majestic sight in all of space exploration? A fully stacked rocket slowly rolling out of those giant doors, beginning its 8-hour crawl to the launch pad. It's that moment the vehicle leaves its birthplace and gets ready to meet its destiny. The VAB has been our gateway to the moon and to Earth orbit. Now, it's getting a whole new generation of rockets ready to take us back to the lunar surface, and, someday, even further. The building is ready, so the only real question is, where will we have it take us next?